Hello, my fellow Almontians, and welcome back to another broadcast from the bunker. Today's due now is 38 to 40, but before we jump into that, I do have one important announcement here regarding grading and that. Please read carefully and listen carefully. When handing in bullets, make sure to take a picture of your work. Make sure your name, period, and the page numbers are on there, and then email it to me. All right? Second, when submitting a CASEL assignment, please take a picture of the summary page with your name on it, obviously, and email that to me as well. When submitting GC assignments, you must hit two buttons. I believe it's a completed and a submit button. If you only hit the one, it doesn't go to the completed file for me, and I don't know that you completed the work. Obviously, you don't have to email these. The GC sends me an email already. Failure to follow these two procedures, folks, will result in a red exclamation point in the portal, and you will not receive any credit for your work. All right? Please, folks, please wait 24 hours once you have submitted your work for the portal to be updated before asking if I received it. All right? So the end of the market period is coming to an end. I know a lot of you guys are scrambling to get some assignments in. Please follow these steps and get your credit. Okay? I left a copy of this in your version of the GC as well. All right. With that being said, let's jump on back 38 to 40 in the GC. Meet me there. All right. Hopefully you spent some good time on these here. Let's check it out. For number 38, it says the diagram below shows position of the Earth in its orbit around the Sun. The diagram indicates relative positions of the Earth to the Sun, but the diagram has not been drawn to scale. So the first one here, which graph best represents the relationship between the Sun's apparent diameter? Remember, that's how big something is relative to its size. I'm getting bigger because I'm closer, and now I'm getting smaller because I'm further. For positions of the Earth around the Sun from A to D. Well, A to D is here. We're going to go counterclockwise. So A looks like it's furthest away. That would be that Greek word aphelion, right? So we're getting closer, 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 closest, which means the Sun would look bigger, 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 biggest. And now we're getting further, 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 furthest, which means the Sun would look smaller, 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 smallest. But it's asking from A to D, so the Sun would appear to get bigger and then smaller. And let's see what it offers here. Okay, so from A to D, it's not just getting bigger. It was getting bigger, bigger, bigger until C and then smaller. So it looks like D is your best choice. Okay. And again, maybe you want to label that diagram, right? That's your aphelion distance, right? A for away is your perihelion distance. Okay. That's your summer solstice, so that's June 21st-ish. And over at C is your winter solstice, that's 12/21-ish, right? Plus or minus a day on those dates, don't be stubborn. All right, let's keep rolling. 39, when Earth is at position A, right, there's summer solstice again. Where will the Sun appear to rise in New York State? So during summer solstice, that's not an equinox day. It's not going to rise due east. It's going to rise slightly off of east. And in the summer, it rises north of east, and the winter it will rise south of east. And that north of east path gives you a longer path. If you remember in this diagram up here, here you go. If you're rising to the north of east, you get this much, much longer path. Now, this is at the Tropic of Cancer. This is not how Elmont would look, but it's still north of east there. And in the winter, it would rise south of east. Okay? So we're going to have that north of due east. And for number 40, for an observer in New York State, which event will occur when the Earth is at position C? Well, let's take a look at position C. That's your winter solstice once again, right? So what's happening at C? It's going to be cold. It's going to be a shorter day. Let's see. Minimum apparent diameter, that means the sun will look smaller, but remember, we're actually closer to the sun in the wintertime, so that's no good. Minimum duration of insolation, there it is, dura, that prefix for amount of time in this case. Yes, and on December 21st, we have the shortest day, so that's your minimum duration of incoming solar radiation. All right. If you remember in Elmont, we get about a 9-hour day at this point versus a 15-hour night, right, on December 21st. All right. Hopefully you followed that. Any further questions on these? Leave them in the comment section down below. All right, let's jump back to the lesson. Okay. Couple of beautiful pictures there. We're going to talk about how a stream transports weathered sediments today. We've been talking about weathering. We're going to focus a little more on the erosional part, right? Erosion is the transport. Weathering is the breaking down. Erosion is the transport of that sediment. And remember, water is the #1 erosional agent. It transports sediments further, longer distances than any other of the agents. And today we're going to focus on rivers. All right. Classic face, right? A little blast from the past. You guys know Michael Jordan. Which picture is the youngest Michael Jordan, and how do you know? Well, look it over. Hopefully you're going to choose picture A, yes? Certainly, and you knew that. You can tell just by his overall appearance. If you ever watched him play, he was quick as anything, lightning speed, amazing shots. If you asked Michael Jordan C here to play the same game as Michael Jordan A, obviously wouldn't have as much energy. And rivers are the same thing. As they age, they go through that life process as well. And as they get older, they get a little slower and they get a little wider, right? We get a little wider as we get older. So which one of these pictures do you think is the youngest river? Well, hopefully you would choose B, right? It is certainly the most energy there. It's going the fastest, the steepest, and that has a lot of life ahead of it, whereas these other ones, you could tell, are getting a little wider and slower. Okay? Okay. So rivers go through a life process, in a sense, just like humans. All right? How does a stream evolve over time? Make sure you get these in your notes. The pictures kind of spell it out nicely there. A youthful stream will be straighter, steeper, have that classic V shape cut into it, right? Rivers cut Vs. And as it gets older, or should I say more mature, the floodplain will widen, the river will slow down, it won't be as steep. You'll start to develop curves, right? As humans get older, we develop curves. And finally, the old age, right? The meandering river gets crazy. Some of them get so big they get cut off. And you start to make what's called oxbow lakes, right? That used to be a curve in a river, but it got cut off. Natural levees, that's these huge areas next to it here, next to the floodplain, right? The levees are over here. It's just a natural process of a river getting older and carving into the land. And they will keep carving into the land until they hit sea level. And when they do, that's about as old as you can get. Okay? Watch this little picture evolving over time and maturing and, of course, eventually cutting itself off. And there's your Oxbow Lake. I left that sequence for you in your iPad there. But one more time, that's younger, getting older, and eventually you cut off to make an Oxbow Lake. Okay? Several ways that water transports sediments. Look at the diagram in the top right there. All right. And you see a couple things happening, right? You see the little light things flying through, the heavier things toward the bottom bouncing, and the bigger things still just kind of staying still. One thing you don't see are the things dissolved in the water, right, in solution, but they're being transported as well, right, those dissolved minerals. So streams transport sediment a couple different ways. First off, all of these sediments being transported is called the stream's load. And its load is carried in solution. That's when those minerals and things are dissolved in the water. Suspension means they're held up temporarily. As the water moves, they get pushed, but when the water slows down, they get deposited. Suspension is a temporary thing, right? If a student gets suspended, they're not expelled, right? Suspension is temporary. Permanent would be expulsion. And of course, the bouncing on the bottom, they call that saltation, and that's where the big things bounce along the bottom of the river. They tend to get rounder and smoother as a result. All right. This is a great chart here. It's in your reference tables. Please find it. On the x-axis, you have the speed of the river, the velocity. On the y-axis, you have the name of the different particles, but also their sizes. These are specific numbers to the size of the sediment. These are just generic numbers, right? Range of numbers. So obviously, the faster the stream goes, the bigger and more particles it can carry. All right? And this just breaks it down by size. If it ever asks you if a particle is, a 0.4 centimeter in diameter, well, that's 0.4. That would be in here. It's a pebble. All right? Sand is between these two sizes. Silt is smaller between these two. And, of course, the smallest one we talk about is clay. All right? Break it back to sedimentary rocks. Clay makes up shale. Sand makes up sandstone. Pebbles and everything else makes up conglomerate. Right? You can connect those topics there. Okay? All right. So the faster a stream goes, the heavier particles it can carry. And, of course, the slower it goes, well, it carries smaller and lighter things. Check out this question here. If a river flows from 100 to 50 centimeters a second, well, here's 100. Here's a 50, right? If I slow from this to this, what's the first thing I'm going to drop? Well, I'm going to drop the biggest thing I was carrying, right? The coarse pebbles. And it's asking you what particles will be transported now at that 50 centimeter per second range. Well, everything below the black curve can be carried. So that's clay, silt, sand. Small and just medium pebbles will start to get pushed. But it's everything below that line, and that's why you have that list right there. Slow the water down to, say, 1 centimeter a second. That's here. What could you possibly erode? Well, finer sand, silt, and clay. If you want to push a boulder, how fast does the water have to be going? Well, it'd have to be doing at least 200 plus centimeters per second. Okay? That's how that chart works. How are the sediment size and shapes affected traveling long distances? Well, take a look at the progression here. They start out angular and large, and they get smaller, smoother, and rounder. And, of course, those are beautifully weathered stones because they've been transported in a river so long. All right. Transporting sediments, well, you start angular, and, of course, your shape, size, and mass will change. All right. Get to your little summary chart here, and first off, let's look at some parts here. This flat area next to the river is called the floodplain. Great for farming and that, right? Very rich nutrients, but not a good place to build your house, obviously, because if you get a lot of rain, this river is going to get higher, spill over its banks here, and you're going to get flooded out, hence the name floodplain. Remember yesterday we talked about the inside and the outside curves. Well, here's your outside curve. Here's your inside. So you get more erosion there, more deposition here. That all changes over here. There's your outside this time, your inside that time. All right, we're going to relate these diagrams to that in a second. That's a cutoff meander, right? These curves are called meanders. When we cut them off, remember the name? Oxbow Lake. And that means the river is getting older. So here you go. Match up these profiles with the river. Take a minute. All right, for the first one, if you take a look here, that's the outside. You're going to have more erosion there. So at W, it should be deeper Well, that's shallow on the left. That's deeper on the right. I'm jumping ahead here out of order. But this one certainly would go there. From Y to Z, the outside is on that side, so you get more erosion there. It would be deeper there. That's why you got to squeeze that one over there. The deeper part here, we said the outside curve. That one's going to squeeze in there. And this one is showing you no curve. It's kind of a straightaway, so you would get more of a symmetrical profile in there. All right. Label your two names, right? You got your floodplain in the back and that cool-looking lake, that Oxbow Lake, forming from rivers that get old and cut their meanders off. Okay. A couple of Regis questions to wrap it up. There are 4 quartz samples. That means they're all the same hardness, right? Quartz has a hardness of 7 out of 10, right? Very hard mineral. Which one has been transported the furthest? Well, if it was transported furthest, it was in there for a long time, so it would get smaller and rounder, and hopefully you chose number 4. Here's a little setup that we do something similar in class. Hopefully we'll get back soon to try this out. Placing a second block under A, well, that's here. That would raise the table up, make the water go faster. And if the water goes faster, you're going to have more erosion. So hopefully you chose choice 4, increase the rate of erosion because the velocity increases. Okay, hopefully that made sense to you. Remember, how do I ask questions? Remember, just put them in the comment section below or hit remind. And once again, folks, reminder, please, 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 if you want credit for your work, and I know you do, make sure for your bullets you take a picture of your work, your name, your period, the page numbers are on there, and email it to me. Submitting CASEL assignments, please take a picture of that summary page and email it to me. Google Classroom assignments, you got to hit 2 buttons, not just one, it's 2 buttons. Complete it and submit, I believe, to get credit for that. Without doing that, folks, I'm not able to see what you completed. I can't get you credit. All right. Again, I try to update the portal every day. Give me 24 hours. It'll probably be in there before then, but give me 24 hours before asking if I received it. All right. Be well, folks.